Well, hi, and welcome to my shop, and thanks so much for coming and joining me here today. I hope to have a lot of fun with this radio, with what I have in mind for it. If you're a regular subscriber and you've been watching this series, you've probably noticed that I disappeared for the last 4 or 5 days. I'm typically working in my shop for an hour or two, posting a video an hour or so long each day, and I miss the odd day, of course, because I have other things going on in my life, but didn't post anything for the last few days, and the reason is I fell on the stairs in my house and cracked a rib in my back, and I couldn't even stand up. But today, I've recovered easily, sufficiently enough to be in here, get back to work, so I'm pretty excited about that, really. I hated 3 or 4 days there just laying on a couch. I hated that. So, okay, now how about the radio? So the last thing I remember doing with this radio is aligning the broadcast band. And at the end, I kind of hemmed and hawed and said, well, that's probably good enough. But I don't know now. And I think I want to pursue what was going on with the alignment of the broadcast band a little bit further. And what I'm really talking about is, in this radio, there are 2 oscillator adjustments for the broadcast band. There's a slug coil adjustment for the low end, and then there's a trimmer capacitor for the high end, which is mounted right on the tuning capacitor. So I followed the instructions as best I could, and the end result was the capacitor at this end is wide open. I couldn't open it anymore. I couldn't reduce its capacitance anymore. It's probably down to a picofarad. Yet I cannot get this radio to align on the scale here. Sort of at the end of the last video, I just kind of, who cares? Well, I've had quite a few days to think about it. And this is something I've encountered over and over in radios, where the trimmer involved in tuning something, and maybe not only the oscillator, but maybe RF or antenna adjustments and that, the capacitive trimmer ends up open wide. And I don't detect the peak, or I can't move something to where I want to move it. It's out of the range of the adjustment. Well, this particular radio, because it has an adjustment at each end, so this end, when you adjust it, will move this one a little bit, and likewise this one, when you adjust this end, the trimmer capacitor, will move this one a little bit. And so you might have noticed, or you were watching me on the last video, I was trying to kind of push things around and just trying to somehow get both these things to generate, to resolve properly. And I just left it, as I said, with the capacitor open here, and the inductor adjusted such that this was fairly accurate down here. This is where all the stations are that people listen to around here, anyway. As if somebody's listening to AM radio. Who's listening to AM radio anyway? So I want to pursue this because, as I mentioned before, I've encountered this a number of times. It doesn't quite make sense to me why this happens. In the past, I've just kind of written it off, especially in the earliest times. So I want to pursue this a little bit further, try to figure out what has happened to this radio, and maybe many radios, that you encountered this kind of problem. So let's just take a look at that capacitor here. See if I'm telling the truth. I think it's a little hard to look at, actually, because all you can see is a screw head in here. I think that's the guy. Wow. So the first step along the way here, I think, is to once again attempt an alignment on here, and see if it doesn't resolve itself. Maybe I just didn't work it enough. Maybe that's all it was. I quit too soon. I should have kept pursuing it. So I'm going to set things up for that and see if we can make some kind of improvement or discover what the nature of the problem really is with this radio, and like I said, maybe others too. Oh, okay, let me first correct something I said about this radio just before we look at the schematic. And it has to do with where the trimmer is. So, looking down in the radio now, there's a nice 3-section capacitor here. The oscillator control for the broadcast band is here. Oh, here. It's this one. And you can see it's not open all the way. I just kind of forgot how I left it. Sorry about the lousy camera work here. Maybe if I come from this way. It's just hidden behind that bracket. So that's the high end of the broadcast band, that central adjustment there. What's with my camera? And the correct low end oscillator control is this one here. Fourth one out, one on the outside. Okay, not that that was a big deal. Let's take a look at the schematic. Okay, so on the schematic, the way this one's been drawn, this is the 3-section capacitor. They've forced it all into one place here. Usually the sections of the capacitor are schematically shown here and there and elsewhere, but in this case they've drawn them all together, which might be a little bit convenient, I guess. And you can see that we have this. Okay, so one of these is the tuning capacitor and the other one is the trimmer, and so this note must be referring to this section. So that's 10 to 480 or 490, 10 to 4, or maybe it's 450. Let's just zoom in a little bit, but I'm not sure I'm going to be able to read it. It looks like 490, 480, 480 or 490, something like that. And then the trimmer is 2.5 to 17 picofarads. I'm thinking about how I could measure this capacitance here. I'm not sure I can without disturbing it. It's a relatively small capacitance, so it's tricky to measure it. So we follow, so here's the ground, the frame of the capacitor and everything. Here it is, grounded to the chassis. So this is the business end, and this is the, what is it? C12, C13, C14, C2, 3, and 4. C2, 3, and 4. Well, this must be the big capacitor numbers here. C12, 13, 14. So let's just take a look at that. C3, C4, C2. Oh, that's pointing at the trimmers. Well, what about the big capacitor? Well, I should be able to figure out from this. So this is broadcast RF trimmer C3. So C3. That should be the key that'll get us to the correct section. C3. So pictorially, this is matching the radio. This is in the middle of the 3 adjustments. And it's shown in the middle here on the diagram. So I'm pretty sure C3 is referring to this. Now, typically they put dotted lines in here to show that these adjustments are ganged, but they didn't do it in this schematic. Okay. So my question would be, since it appears as if I cannot trim down the capacitance sufficient, is this circuit somehow acquiring more capacitance from somewhere? So let's just follow the wire and see where it goes. It's down in the switch here. I think you can see it connects. Oh boy. I think it's connecting to this one. Right in and right into the converter. Does that make sense? Oh boy, if this is related to an oscillator, it's got to work. No, that's not quite true. So we're trimming. I didn't even say it, but believe me, it wasn't true what I was going to say. What about this other wire? Because it looks like it might be here. Crazy trying to follow these. We're up to here. BC RF coil. This looks like this must be the connection. So in other words, this capacitor is working against this coil. No, geez, if you don't get this right, I mean, all the other bands are thrown off too. Isn't this used as the main tuning capacitor all the time? Sure it is. And you're adjusting the trimmer on this once for the broadcast band. So it could be if you get this out. Oh, well that's interesting. If you get this out, yeah. Well, again, what's in my head is interesting, but I haven't shared it with you yet. If you get this out of whack, then perhaps all the other bands are going to be out of whack to some degree too, because you're just, yeah, I don't know. Okay. So let's follow this again. And now we're looking for any source of capacitance, any capacitor that might be in this circuit. Still not sure what to make about this. So I think this is the this looks like this is the ring connector, so it's always connected, and then you're selecting either here or here. The radio is currently shown in broadcast mode, I think that's what they're showing. Oh, and there's a little warning I mentioned about my injured back. I still have a cracked rib in my back, so if I, as I almost did, clear my throat and then moan immediately after it, you'll understand what's going on. I dare not sneeze, I'll tell you that. If I sneeze, I think I'll be on my way to the hospital. And don't laugh, Jim, don't laugh. That hurt too. No joking about today. So, what exactly is going on here? It almost looks like if you flip it into the position it's shown, the wire coming from the capacitor is splitting, or connected to both what looks like number 8 and number 12. Maybe that makes sense. Because you're bringing in this coil perhaps in parallel with this. I guess that would be the case. Here's the coil down to the chassis. And then this line you're selecting on these for the different bands. These are all going up here to these oscillator coils. You're basically selecting which coil you want to operate against this capacitor. That's how you're switching bands. So there must be a coil involved, so this wire has to be involved. This one has to be involved because it's the one that reaches the coil. Okay, so right up here is a capacitor going to ground. So this capacitor to ground is essentially connected. Right here. So here's another capacitor to ground paralleled with these. Now, where'd it go? Right here. What does it say? Oh, interesting. C25 8.2. It's a tiny capacitor. And it says 981, looks like A, 4.7 in the 981X. And now this is the important thing. 20%, I think is what it says. 20%. That's indicating it's not a particularly precise capacitor, but then it could be that you install this capacitor when the set was built and it varies, 10 or 15%. It's compensated for during the alignment process. But what if this one's really out? Now so this is the end of the line, because here's a ground here, so this is it. I gotta find this capacitor, check it before I do anything more. Now now I'm gonna make the fatal mistake of, first thing you find, you think you're done. Maybe there's another one somewhere. Let's follow that other wire carefully. That's a big problem with people when they face problems. A big problem with people when they face problems, yeah. You find one thing and you think that's probably it. Now here's another one, but I changed this one. This has been changed out. The other side, we're getting quite a distance away now. Could any of this kind of stuff? Oh, look at this. Nothing is said about this that I found. This is the gimmick. So it's on the other side of this guy, 0.005. So you might think that for the most part this capacitor electronically doesn't amount to much. The signal passes right through it. And this one's tiny in comparison too. Of course this is not through it. This is, where is it going? It's going, so this you know what this looks like? This looks like a, I'm not going to get the word right. So this is between these two grids. You have a tiny capacitor between grid 1 and grid 3 built this way. Bigger. C56 approximately 2 picofarads. Cap coupler. Capacitor coupler. So it's feeding some amount of signal back or between these two grids, and it certainly has an important purpose which I can't describe right now. I remember reading about this kind of stuff. Could be, yeah, you know what's coming in mind? Neutralization, but I don't think that's quite right. I think if you're going to neutralize, you would come from a plate and capacitor your way back to the grid or something like that. This is definitely on grids. So what if this is wrong? Is this affecting? It's only 2. How wrong can it be? If it's 2 picofarads and it's 4, what does that matter? That's still a tiny amount, and it's quite a distance from what we're concerned about. And I've seen this on the radio. It looks like it's original. It doesn't look like it's been disturbed. I think it all amounts to this one. Where'd he go? This one. Let's find this guy and change it out. Maybe what I should do before I do that to make this, oh, I got the base plate on the radio. I'd have to take the base plate off to get at the capacitor. This project's getting big already. So I think the first thing I'm going to do is I'm going to do the alignment activity on the radio, clear my mind as to where it stands right now, just in case I'm mistaken. And my memory got erased while I was laying on the couch watching useless television for the last 4 days. Yeah, I think that's the way to go. I'm going to fire the radio up, get it operating, do the alignment thing, and just see if I can fudge it in there. Maybe there's some more I can do experimentally with it. Okay, let's get it fired up here. I'm fired up. I really, I can't stand watching television all day like that. Oh my gosh, I did watch some great stuff on YouTube. Fantastic stuff. Astronomy stuff, things like that. Okay, we're gonna switch this on first time in a while. So we have our amplifier. Good. And volume down. Here we go. I haven't done anything in here, so it should be cooking. So I'm using 2 signal generators. I can explain this now. One of the things that I thought about while I was convalescing was, if I'm going to do this alignment at both ends of a band, I have to reset this over and over and over. Why don't I just get 2 signal generators, because I have to, have one dialed up for the high end and the other one dialed up for the low end. That's what I've done. I've got this guy set to, and he's drifted 600. And this one I got set to 1500. And I've got them, I'll show you how I've got them connected. So the outputs from these 2 devices, this is one here, the other one is somewhere on my bench here. All I've done is grounded the ground wire from the chassis wire from the equipment to the chassis, and the signal wire I've just clipped onto this antenna wire that's sticking out the back, the mysterious wire that bypasses a little capacitor. So doing this turns into a little capacitor, just clipping on. It's on the insulation here in case you can't really see it. It's not actually making any metallic connection, so that's a loose coupling all I got to do is just boost the power output of my signal generators until it comes through. So I'm thinking, if I connect my equipment straight to the antenna, I should be using their suggested interface circuit, but I'm going to do it this way. Could that be the problem? I don't think so. Hey, where's the sound? There we are. Very good. So I got them both going. So let's go see what we hear at 600. Now I probably don't have enough signal. Not much. Okay. Yeah, I got almost no signal going here. So this is an unmodulated. That's right. This is unmodulated. So there's going to be no tone. Instead, we're hearing a hiss, which is a little bit curious in itself. Let me just tune the radio a bit. Well, it's right on 600. Dead on 600 here. Okay, now what do we got up at 1500? Seems pretty sensitive up here. Just adjusting the volume control here. That's really not very bad. Well, let me just wind up. That's really close to 1500. What am I so wound out about? This is really close. The that trimmer is not open all the way, like I said. Oh, smokes! I should have done this first. Okay, let me. I wonder if I got confused. It does happen from time to time. Oh, don't laugh. Don't laugh, Jim. No chuckling. It must be serious. Don't laugh at your own jokes. Okay, so we got to put on full power too. That's an oh. Check it again. Did it move off there a bit? Hey, this is great. 2 signal generators makes this great. Where'd it go? There it is right there. Perfect. Like, parallax in your view, but not in mine. So we just want to knock this back to here. Why can't I do that? Okay, onto the trimmer. See if I can make our meter work a little better. There we are. Okay. Picking the correct trimmer. Yeah, from time to time I make mistakes. Okay. Stronger. Okay, I'm opening it. It's kind of a scratchy noise when I do that. Okay. I went the wrong way, if anything. Let's tighten it down. Maybe it was tightened down all the way. Ah, what a lousy memory. I know. This thing isn't moving at all. What stupid thing am I doing here? Doesn't sound like an oscillator at all. I'm boobing it up here. That sounds like. So what I just did. Be careful now. I'm holding on to my camera tripod. I don't want to touch things. So I'm adjusting this middle one. It really just sounds. It really just sounds like an RF. I'm going to adjust this one. If I put my finger near the stator plates. See the radio retune. Why did I think it's not that? Okay, you know what? I hate to do this. We got to go back and look at the document here. Oh, BC RF trimmer right there. BC antenna trimmer. Oh, I got it wrong. Totally wrong. BC, I was right the first thing I said, and then I corrected it. Oh my God, what a mess I'm making of this. What a mess. Well, it's supposed to be adjusted at 1500. We're at 1500. So it's, I'll adjust it where it is right now, and then we'll do the correct trimmer, which is the one I said it was right at the start. Oh my God, what? Yeah, never any confusion, never any mistakes. So I'm just going to set the RF trimmer for peak. I think it is there actually, but let me do it. That explains why this trimmer wasn't right open, because it's this one, and it is open. Okay, so now we're going to try to get 1500 onto here. This is about 1510. And we got 1500 on the signal generator. So if I close this, does it go that way? It's faded out because it's retuned. Where is it? No, it's going up. Okay, so yeah, okay, now I am where I thought I was. So we open this guy right up. We can't reduce the capacitance that's confronting the that's resonating with the inductor we saw in the diagram, unadjustable inductor. So what am I saying? Oh, I'm saying I gotta stop for a minute. No, why stop? Keep going, man. So that's open. We're back to that original theory then. That other capacitor may be interfering with this whole thing. I gotta find that little capacitor. Let's think about this now. If that capacitor is, let's look back at the schematic here. Thinking about it is pretty dangerous. Let's do that. It's good to live with a little bit of danger in your life. So it was this one. So this is additive to this one. How can that trimmer I'm adjusting be located in the chassis when right up on the tuning capacitor, on the gain capacitor, is a trimmer? The trimmer would be, pictorially, it's going to be. So this is the oscillator. So so like 2. You see, the problem here is I don't have the actual instructions on how to do this. The actual instructions are on some other page. I don't have it. So I got some diagrams and some hints. I just overlooked something here originally. There's actually 2 capacitors. Why would they do that? 2 capacitors? What are you talking about, Jim? And what I'm talking about is I think the trimmer, there's a trimmer mounted on the gain capacitor, and then I'm being directed in the other diagram to use this as the broadcast oscillator trimmer. C6. Do it at 1500. C6. Okay, let's C6. CC6. C6. So definitely not these. So C6 is going to be somewhere around these coils, I would think. A variable, a trimmer. Well, it's going to be related to the broadcast oscillator. So it should be related right in here. So here's the adjustment at one end. This is the 600 adjustment, 600 hertz adjustment right here, I believe. That's what I'm looking at. Somewhere there's a C6 variable capacitor affecting this. And all kinds of wires going down this way. Here it is, C6. C6, 33. 2.5%. Temperature. Oh my gosh, really? Temperature compensated capacitor? Oh, I just need to heat it up. Well, here's another variation in the set. This capacitor. Here's another one. Okay, not to worry about that. It's just something. Here's a whole pile of them. Here, look at this. I gotta pay closer attention to these little notes if I'm gonna chase down my radio, which is the X version of it. So in that case, oh, looking at this one. Yeah, no, C19 over there. C6 from 4 to 30 picofarads trimmer. So this is trimming. What's it trimming exactly? Let's chase the wire. Let's just follow the wire for now. So it's affecting this coil in a very similar way. Wait a minute, how do I get over here? Because I believe this is an oscillator adjustment. Maybe I got that wrong. C13. 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 This is C3. What's happening? I'm losing my mind here. BC RF trimmer. C3. Right. C6. Oh, I get C13 in my head. I better just go back and lay down on the couch for a while, I think. C13. Because I saw it on the schematic. You know, just another thing that's really freaking me out here is when you read down here, it talks about the chart right here. Perform alignment in proper order as shown by the accompanying chart, which I don't have, starting with number 1 and following all operations across, then number 2. So, you know, I'm not doing that because I don't have it. And where is it? It's on a sticker fastened to the bottom of the chassis shield. Not on my radio, it's not. Why, that'd be smart to try to find this. Already done that and didn't find it. Wait one cotton pick a second. So what radio is this one? This is not my radio. No, this is totally different. This is definitely my radio here. No question about it. Okay, let's see if I can straighten my head out again. This seems to be the challenge today. It's just getting my head around all this. So we're starting here with this central part of the tuning capacitor. This is the oscillator part of the gang tuning capacitor. Oscillator for all bands. Oscillator adjustment for all bands. Tuning adjustment. This is the antenna adjustment, and this is the intermediate stage adjustment. RF adjustments. This has a trimmer. I think what I'm discovering here is I just kind of missed the dual trimmer situation at 1500. Now, this doesn't actually say 1500 or anything, but what if we go to the other diagram again? So here it says right there. Oh, no, here. Oscillator trimmer at 1500. Shortwave C-band oscillator trimmer. Broadcast antenna trimmer. So I got these mixed up, or they don't match the diagram. Because in the diagram, I think it's pretty clear that the center one is connected to the oscillator. Just like I said, oscillator, intermediate, and antenna. But in fact, it's broadcast antenna, broadcast RF, and then it's a short wave band oscillator. And it's step number 6. I think maybe I just messed this up rather thoroughly. Or I'm messing it up today. So can this one have some effect? I mean, this must be the tuning capacitor for the whole radio, for all bands. Let me twiddle this one a little bit and see what happens. And this is the one that is closest to the shaft. Okay, so I'm going to adjust this one and see if I can kind of get this one back into its own zone. And then we'll work, when we get to this step, I'll be aware that fooling with this will knock the other thing off. Oh boy. Like, there has to be a tuning capacitor involved here, or there's no tuning the broadcast band. So, you know, you could have a switching arrangement where you switch this in for certain bands and you switch in a different one for other bands, but there is no other one. I find it all rather confusing. C4 1700. Wasn't there trouble on this one too? Okay, I think I've talked enough. Let's go back and see what we can do here. I did say something about having fun with this radio today, didn't I? This is what fun looks like in my shop. My voice gets a little hoarse. It's because I'm refusing to clear my throat. Okay, so we're going to fool with the C3 and see what happens. Yeah, this is the one I put my finger on and it jumped. Look at that. We'd want this to be is these trimmers to be pretty much in the middle of their run. This one's wide open, so this is the... Let me tighten this one down. A little bit. Anyway, so it's more in the normal range. Normal range would be something like that. Show how close we are now. Okay, so I figured this out. That was not at all what I was expecting. I didn't expect to find out there's 2 trimmer capacitors involved. So we're at 1500. Right on the money. Make sure we're tuned. That's good enough. That's good enough. I'm going to look at how jammed this scale is here. I mean, really. If I just move my head left or right a little wee bit, the pointer looks different. You know, it's sticking out a fair bit from the glass. So, you know, how good can you get these things? Well, let's find out. You get 1500 there by moving the trimmer that's right on the tuning capacitor. I'm gonna try anyway. Okay, so this one had a large range on it, I think, if I remember right. So that's open quite a way. So I'm going to close it a bit. And then I'm going to open the other one. Yeah, see how they're working together? They're adding. They're in parallel. Just exactly right. Oops, can't tune it right. Yeah. Okay, now did we wreck up the 600? I can see the magic eye in there. You can too. So it's a little hard gain. It's an unmodulated signal. So it's gone below just a wee bit. So we'll move that up. Of course, I'll turn the wrong thing at this point and destroy the whole effort. Here we go. $600 exactly. Okay, so it's wandered off a bit. Put it where it should be. Let's see if we can find it with these trimmers. This way. Okay, so one trimmer's way out. So I'm going to close it in a bit. We'll use the other one. Because this trimmer has a huge range on it. And actually that's out of its range. So right on the end of the adjustable range. Do this one too. Straight out. Then we're going to go to the 17 megacycles right away and see what's happening. Very good. I like it. And the RF is adjusted at the high end, I believe. It's a trimmer. Let's go up here again. As I fiddle with the RF, let's just make sure it's correct. Well, it wants to be all the way out. Okay, let's go to 17 million. 17 million. Okay. So at 17, got this light staring right at you here. Going to cover it a little bit. Didn't make much difference, did it? Okay, I'm going to solve it this way. Oh, I'm going to cough. Don't cough. Oh, I spoke German. And I witnessed, yeah, good word for me today. Don't cough. Okay. We're on 17 megahertz. And even the pointer is not necessarily perfectly straight either. You know, really killing myself here. 17. You know, when you have the band spread bands, these little adjustments don't matter because you can really get this aligned very precisely. These bands that aren't band spread, good luck on them. There's a broad range of frequencies here again. Tough. 17. Let's go to 17 megahertz. What, did I get rusty while I was couching? Well, I didn't hear much. Let's give it a bit more juice here. There it is. Thought I heard it. That's funny, I thought I heard it. Let's give it all the power in the world here. Oh my gosh, look where it is. This'll never do. So now if I want to put this on 17, that'll force this oscillator trimmer that's right on the big capacitor. Oh, I just touched the screw. Look at how sensitive it is up here. Oh my gosh. That's not very good, is it? So we're going to close it down so it's quiet. That's pretty good. No, that's not good. That's 16.2 that's 16.290. That's way off. So we want 16.290 to move down here. It's a wonder you ever get these right. It's like a lot of things in life. You don't necessarily get things right. You do things until you're satisfied. That's a really important thing to realize in terms of investigations. So like for instance, a police investigation in particular continues until the investigators are satisfied. They don't know that the truth is known. They've just become satisfied. They might think the truth is known and that's why they feel satisfied. So that's why a lot of investigations have extremely objective processes. So the investigator is not winging it. Oh, I'm just back to putting the wrong frequency there. Oh, see, it's jumping right past it because of this situation here. Not moving much. Now this band, does this band also have an inductor? I'm sure it does. Why don't we see if we can move this on this band with its related inductor. I know it's the wrong end, but let's give it a try. Maybe I just align this thing way out, all over the place. So I'm going to peek at here, and so for this band there may not be any adjustment. 25, there's only the one I'm doing, I think 25 meter C band, the one I'm doing. That's it. So this is your only way you can adjust the so these two kind of set that main tuning capacitor up for the rest of the other bands. So really it's the adjustment of this band is adjusting the trimmer right on the tuning capacitor. So wouldn't it be more sensible to make this work at 17 megahertz properly and then go back to the broadcast band? But that's not the order they're showing it. This is number 6. What was number 5? Oh! Ha! So step number 5 reads like this. 31 meter and C band. Core L17, L18 at 95 kilohertz. So what they're saying is, when you do step 5, which is just before the step I'm doing now, you're adjusting it looking at the 31 meter band, while in fact you're affecting the I'm hesitating because it doesn't say oscillator. Oh, the rest say oscillator. Why didn't they say oscillator for 31 meter band? Okay, I'm looking at the diagram. Is there another adjustment for the 31 meter band? No. For some reason they didn't put the word oscillator in there, but I think that's what it has to be. That. So let me twist it. We're on this band, and we're gonna twist the adjustment for the 31 meter band and see if it does affect this one. And maybe this whole thing is kind of just radiating through the whole radio here. Once you get a little bit out, you can't get it back. Here we go. Oh, look at that. I barely moved it. That's the big discovery here. I don't have the detailed instructions, that there are some complications and some surprising things with multiple trimmer capacitors in parallel for same band. Inductor adjustment on one band affecting another band. Therefore, the adjustment of this band is going to affect the broadcast band. Holy smokes. Okay, so that's enough in my head right at the moment. I'm going to stop for a bit. And I'm going to go see my cats. That's what I'll do. And then I'm going to carry on with this and see if I can't resolve the whole thing. Okay, let's look this over closely here. And my cats, hey, they're real happy today because the neighbor's chickens are in my backyard running around. Cats love the chickens. Everybody loves chicken. Okay. So if we look at these in the proper order, it's of course 1 and 2 for the IF transformers. 3 is the low broadcast oscillator core adjustment. 4 is, there's a 4, and there's a 4. These two are RF trimmers. This is the high-end oscillator. So you would first do the low-end broadcast, high-end broadcast, peak these ones up at that point. Now you go on to number 5. 5 is the 31 meter band. And when it said NC band, now I realize, yeah, you are actually adjusting the C band. And then I guess on number 6, you then finally adjust the C band. Really? Right on here? Wow, that doesn't make sense to me. You'd think this would be the first thing you'd want to adjust to get this stabilized, because surely to goodness, if you move this, you're gonna adjust everything. Maybe in the detailed instructions it says you got to go over these again and again and again. I don't know. And then you're on to number 7. There's 2 7s. RF trimmer, and here's the, so 7, 8, I don't even have to worry about that. So the next step really though is this 9500. Let's check this band and see where it is now. And there's no capacitor for this because there isn't. Right. Okay. 31 meter band, 9500. Second control in from the edge. Did I say 95 meter band? Is that what I said? It would not be the 95 meter band. 31 meter band. We're doing it 95. What did it say? I gotta do this exactly correct now, or I'm gonna mess up. I don't want to mess up this time. With these things, I find often I gotta go through them a couple of times just to get it straight. It was a really good example of that here. That's for sure. 31 meter band, 9500. Okay, so we'll go to 9500. Right there. We'll find out. 9500, eh? No, it's right at the edge of the band here. I can get there. Sound. Should be hearing this. I got this thing just blasting away here too. How come we didn't hear any of that? It's up full. 9,500. 9,500. Wow. I don't remember one of these bands not working. Okay, that's as low as I can go on this band, so we'll go up. Not appearing. Now we'll go up. We'll come down from just above 95. Didn't hear it. Okay, so go 95 down. Oh my gosh. I don't remember a band not working. Let me put this on full blast. There it is, right at 95 almost. This is a stupidly strong signal for a radio like this. Let me turn down the volume. Now, I am doing a... Well, it's very close, isn't it? This is right on 95. So let's adjust that so we're right on 95. Let's get it right here. I don't want to do the wrong one. So this is the second one in from the apron. I want to make this 95 here. Wow. Hey man, where'd you go? Kind of funny about this control here. I think that's going to do it. There's nothing else to adjust on that band. There's no RF adjustments. That's just for the broadcast. So the capacitor has 3 sections. 2 of the 3 sections are antenna trimmer, are antenna and intermediate, just for the broadcast. Or at least that's how you adjust them. Okay, so we got this correct now. So the next thing is to go to number 6, and 6 is the 17,000. Well, that's good, 'cause that's 95. Yeah, so this band covers what these other bands cover. So you should be able to pick everything you pick up here. You should be able to pick up down here. You could think of this as a band you go to and you sweep around. Look, anything happening today? Hey, there's something here. You go, oh, 95. I'll go up on this band and listen to it. I think that's kind of the idea of this broad thing here. See what it says there? AMTR. Well, it looks like an amateur radio band. There is an amateur radio band right in here, but I think it's a little more this way. And there's also an international broadcast band right here. So AMTR. Here's another one over here. AM. AM. Just above 14. I don't know. I'm just looking for any hint, anything at all that I'm overlooking that I need to pay attention to. So 17. 17. 17. Very powerful signal. What has happened? I'm on a I'm on the non-band spread, so it's going to be very sharp and sudden, so maybe I'm just going too fast. Really? It's extremely weak at 16. So that looked, I think that would be an image. Didn't we find 16? We found 16.2 or something happening up here. Well, maybe having adjusted the other band, now we're just a little more in the zone to adjust this one. And in order to not boob it all up, look at the chart, it's the shaft and trimmer. Just following the instructions now. Adjusting the C band. Coming open. We'll never get there. We're never going to get there. This is open as big as you can do it. 6.3. 16.3. So maybe the other concept here, as much as this radio may have been very accurate when it came out of the factory, the accuracy down here is not terribly important, because you're going to kind of find out there's activity up in this. Oh, well, that's this band. So you jump up on this band and listen to it here. So getting these band spread ones working really well, if it involves forsaking this band, because people are listening to shortwave like crazy. Actually, I don't think anybody's listening these days, because I'm not. The solar situation is so poor right now. So that would mean don't push this. But I've already adjusted it, and that has adjusted the broadcast band, because they're related. Is that really what's happened? So let's say this is as good as I can get on this band. Good enough. 6.3 when it says 6 point. I mean, look, there's 6.3. Maybe a little bend in the pointer here is enough. So let's just see what's happened to the broadcast band. Oops. There we are. So I still have almost 600 here. Okay, 600. It's pretty good. 1500. No 1500 here. 1500. Wow! Look at the difference in the sensitivity between this band and what just happened here. Wow. That stupidly strong signal is definitely stupidly strong. I don't have that there now. So, or just a little, no, actually I'm a little higher. Well, I really can't complain about that. Can't complain about that. So what do? So we did the 31, the C band, and this one is hung in. So yeah, that's really good. That's good. Let's just check the different areas on this band. So if we go down right there, that's supposed to be 9.450. 9.450. Stupidly strong signal. There we are. Hey, that's what it's supposed to be. Excellent. Now we'll go. So these spread bands are intended for you to pick off the exact frequency you're going for. So you look in your World Radio and Television Handbook, get the frequency, and you could dial it right in on this if this radio is properly aligned. So let's go to the other end, 965. Conversely, I should be able to pick stuff up, read the frequency, and then look on the internet and see that it's actually true. 9.65. So we're a little out here. So these are really, this is really, like these bands are the ones to concentrate on, not this one. So we want that to be 965. Wow, it's really, really close. Let's put this on just onto where it should be. 9650. Watching an old Frank Zappa video on TV. Frank Zappa, very interesting musician, being interviewed by Dick Cavett, if you can believe it. And then he's alone with his guitar, and then Dick says, "Oh, will you play something?" He says, "Sure." He goes up on stage all alone. Dick Cavett's house band starts playing some basic background music, and then just a moment, he starts playing his guitar and does the lead guitar type thing. And holy smokes, I'm sure it is not a rehearsed thing at all. He's just listening to the music that's being played and figuring out what he can do to match it. Very skilled. What a great musician. Strange guy, though. So where is 965? That's what we're doing here. I'm losing my concentration entirely. So if I wanted to dial in 965, I would dial to here, but in fact it's sitting over there. Let's see if we can fix this. The 31 meter band has only one adjustment. Now, is that true? 31 meter band. Done at 95. Wow. I'm just going to go down to 95 and see if it's still where it was. I think it is. And if it's accurate here, there's really, I shouldn't fool around up here. I'll just make it inaccurate down there, and then I want to follow the instructions. 95. What the heck? Blast it. Yeah, it's bang on. It's bang on. Okay, so what that's telling me is I'm basically getting as much out of this radio as I can, I think, at this point. It does seem to be quite insensitive, but then I'm really not running it on the antenna, right? I'm just clipping my generator. Hey, let's put it on the antenna, see what we get. I just finished saying there's no shortwave out there to be heard, but that's not necessarily true. You have to check. You never know. You never know. You have to check to see what's going on. And occasionally, bands can open up for a very short period, an hour or something like that. You can miss it. You miss the excitement. The excitement of American religious broadcasts. Okay, so this antenna I'm going to put on now. I have two choices here. I can clip it onto this wire, which bypasses a small capacitor. But I won't do that. I will clip it on to the proper terminal, and the capacitor will be involved. And I'm going to remove these two signal generator leads. Just get them out of the way here. Turn them down is what I really should do. Turn it down. Turn it down. So there's no chance of that doing anything. And my antenna. Here we go. Onto the antenna. You hear that? Wow, that's nothing. So, maybe I'm touching the wrong terminal. So I noticed before the capacitor that's in the circuit doesn't seem to carry much signal. So I'm gonna cheat. We're going right on that wire. We're bypassing the little capacitor on the antenna line. Not hearing much. Wow, that's full tilt. Expect to hear at least atmospheric, cosmic sounds. There's just nothing here. Nothing at all. What have I done? I've done something stupid, I think. Yeah, I did. I accidentally connected the signal generator down on the volume. I did do something stupid. Let's try this on the antenna terminal too. Doesn't like the antenna terminal. I have to maybe change that little capacitor. That's not good. It's a mica capacitor. Can you? Wow. She's dead. This is not going well at all. Is it the band switch? Don't think so. Let's try another band. Oh! Something happened here. Let's go back. I don't know. It almost seemed like the AVC was relaxing when I first flipped here. I go to this band, it's quiet. Is there an AVC voltage in there quieting it? Because when I go up to this band, you'll see it comes up slowly. Even though I flipped it around. Suggesting there was an AVC voltage in the AVC circuit. Beautiful. Okay, so I recognize these are, I think this is Cuba in two places. Every day. Is there anybody else? Nobody else. That's a little surprising. Okay, well, so we're close to noon time. Let's go up on the top band. Anybody home here? No. So, with this band working, that means the radio has the potential to work on the shortwave bands quite nicely. This one seems alright. This one seems weak. I'll let me scan the whole thing with this. Seems weak. Get the volume up full. Expect stuff up around here.
Not only in the past, but also today that species have and are still evolving. I mean, take, for example, elephants. An international ban on the trade of ivory took effect in 1989. At that time, there were about 1 million elephants in Africa, with 7.5% of them being poached, killed every year. Today, less than half of them are left, and the numbers being poached each year have increased.
Oh.
Yeah, it's really sad. Oh, yeah, absolutely.
Boy. That volume is virtually full to hear that. And that's a very powerful station. It's getting stronger as we go. Oh, that's got to be an alignment thing because...
What sands are you talking about? I've already forgiven that.
See, you can hear the atmospheric noise come up. And then there's all kinds of stations. Or is that just the way the atmosphere is working today? Ooh, what the heck is that? That sounds like something going on in the radio. Yeah. More weirdness. Well, that's interesting. Now that's the sound of ham radio. The radio's full on. What happened there? They turned the tone control. They could have stopped transmitting at that very moment. So that's ham radio. It's a digital mode in ham radio. And we can't get that on any of these other bands. Yeah. So notice the bandwidth, the band range is restricted because you can pick stuff up way beyond 15.3. Way beyond. Got something. So works really good right here. Okay, I beat this thing to death here now. Well, I'm going to go away. I'm going to think about this. I'm going to try not to fall on my stairs again and crack another rib. And think about what it is I'm really hoping to achieve with this radio. I own this radio, so I'd really like it to work well. It's a beautiful looking radio. The cabinet's coming along, doing a little tiny bit of work on it there before I fell. So yeah, let's just review here before I go away. Broadcast band seems okay. The 25 meter band seemed okay. This guy has a hot spot right in here. It seems to work really well, but that could be atmospheric effects, but I don't think so. This band I'm not sure about. And this guy quite weak. And this is a really important band, a 9 megahertz band. Hey, lots of stuff on there. Maybe that's what we'll start tomorrow is, why is this band so weak? Again, is it just alignment has not been completed properly? I mean, I didn't really follow the whole procedure here today by any means. Okay, well, I hope you got a kick out of that. There's lots more to do here, I think, just to continue pursuing this whole thing. Great. See you on the next video. Thanks a lot for watching. Have a great day.